Anytime you have all the radicals the same thing. And so notice each of these is the sixth root. And what you can do is you can condense this all into one single root. Right? It's one single sixth root. And then just combine all the numbers together. So 8 times 16 divided by 2. Now, notice I'm not multiplying these out because leaving them in this form is simpler. So 2 goes into 16 how many times? 8. And so really what we're looking at here is the sixth root of 64. Okay, now, what happens when you type that in? It doesn't work, right? Okay, now, what do you notice about 64? It's a perfect power, so it's a perfect square, it's a perfect cube, right? You can choose either of those if you think of this in terms of a perfect power. Okay, so this is, let's say you think of it as 8 squared. Well, what do you know about 8? It's also a perfect power. It's a perfect cube, right? So if we were to rewrite that as 2 cubed squared, what does this wind up becoming? 2 to the, when you take a power to a power, you do what with the powers? Multiply. So here we're really looking at the sixth root of 2 to the sixth. There you go, 2. And so it can simplify to the 2.
You make it look really easy.
All right. Other questions up through 44? Number 44? Here, one of the things, and this is kind of what I wanted to talk about for the problems below 44, and it looks like it involved this number 40 as well. Anytime you recognize a perfect power, a number with a perfect power, think of it in terms of its exponential form. So 64, you should recognize that's a perfect power. So think of it as 8 squared, or think of it as 4 cubed. Either of those would work, because if you thought of this as 4 cubed, 4 is what? 4 is still a perfect power as well, right? It is 2 squared, and then 2 squared cubed still winds up being 2 to the sixth, which the sixth root of is still going to give you the 2.